Hey there, in this video we're taking a look at a technique we use when we're dealing with square roots in fractions. This is called rationalizing the denominator. Well, first let's just review what is meant by this term rational in a mathematical context. The rational numbers are numbers that can be written as a ratio of two integers, where integers are the set of whole numbers, and a ratio is just another way of saying a fraction. So examples of rational numbers are any positive or negative fraction, or also any positive or negative whole number, because any whole number can really just be thought of as a fraction that has a 1 in the denominator, which we don't need to include because anything divided by 1 is itself. Well, then there's also a set of irrational numbers, which are numbers that cannot be written as a fraction using integers. Probably the most famous irrational number is the number pi, which is this decimal that continues on infinitely without ever repeating its pattern. But another very common set of irrational numbers are any square roots that cannot be simplified as perfect squares. Like the square root of 2, if you plug that into a calculator, it will be this infinitely long decimal. Or the square root of 3 is another example of an irrational number. So if we have a square root inside of a fraction, like 1 divided by the square root of 3, that is considered an irrational number. But certain irrational numbers are easier to deal with than others. So before the invention of computer calculators, it was pretty hard to calculate something like 1 divided by the square root of 3, because square roots are these long, complicated decimals, and it's complicated to try to divide by a decimal. So it's easier if we have a square root in the top of a fraction than if we have one in the bottom of a fraction. Now, this is less important nowadays because we can use calculators to simplify expressions, but it is still useful to be able to rationalize a denominator because it's going to make a lot of things that we'll deal with in trigonometry easier. So the convention, which means the common way that we do things in math, sort of like the rules of grammar are the conventions of language. Well, we have certain conventions in mathematics as well. The convention is we don't want to leave any square roots in the denominator of a fraction. So we've got to figure out a way to move this square root out of the denominator. Well, if we want to change a fraction, we know that we are allowed to multiply something into the top and bottom of a fraction, the numerator and denominator, as long as we multiply the same factor to the top and bottom. So how can we cancel out a square root by multiplying? Well, by definition of a square root, any square root of a number times itself just equals that number. So the technique to get rid of this square root of 3 that we have in the denominator is we can multiply it times the square root of 3. And the square root of 3 times the square root of 3 is just equal to 3. But if we do that to the denominator, we also need to multiply times the same thing into the numerator. So 1 times the square root of 3 would give us the square root of 3. So to look at another similar example, if we have the fraction 1 divided by the square root of 5, we don't want to leave this square root of 5 in the denominator, and the way that we can move that into the numerator is by multiplying times the square root of 5. Those square roots will cancel out in the denominator, and we're just left with 5, and 1 times the square root of 5 is the square root of 5. Now let's look at some more examples where we might also have some different numbers in our numerator. So in each of these cases, we want to take whatever square root we have in the denominator and multiply the same square root into the numerator and denominator. When we're multiplying the same root times itself, by definition of a square root, any square root times itself of the same number just equals that number. So square root of 2 times square root of 2 is 2. If we're multiplying a whole number, an integer, times a root, those are not able to be combined. So we would have to leave this numerator as just 5 times the square root of 2. In this next example, we need to multiply again by the square root of 2 so that we can get that denominator to have just a regular number 2 without the square root. And in our numerator, we've got 6 times the square root of 2. And it might be possible to simplify some of these fractions. If we ever notice there's a common factor in the numerator and denominator of a fraction, we should divide by that common factor. So I can divide the numerator and denominator here by 2 and rewrite this as 3 times the square root of 2 all over 1, or anything divided by 1 is itself, so we could just write this as 3 times the square root of 2. In this next example, we need to multiply the numerator and denominator times the square root of 6. Those square roots cancel out in the denominator, and in the numerator, we've got 4 times the square root of 6. And this is another case where we can now simplify this fraction a bit further. The fraction 4 over 6 reduces to 2 over 3 if we divide the numerator and denominator by 2. So our final answer here would be 2 root 6 over 3. And in this last example, we need to multiply by the square root of 6. That causes those square roots in the denominator to cancel out, and in our numerator, we've got 3 times the square root of 6. And the fraction 3 over 6 simplifies. That's the same as 1/2. So we have 1 times the square root of 6 all over 2. Or another way that we could write this is just the square root of 6 all over 2. And let's finish by looking at a few more different cases, including ones where we've got square roots in the numerator and denominator of our fraction. So to rationalize this example right here, the only thing that we need to get rid of is this square root of 2 that's in the denominator. It's okay to leave a square root in the numerator of a fraction when we're rationalizing. So let's multiply by the square root of 2 to the top and bottom. Now we know that if we multiply the same square root times itself, the square root cancels out, so we're just left with 2. If we multiply two different roots times each other, one of the properties of the principal root is that we can then multiply those numbers together and leave it underneath the square root. And that is our final simplified answer. I cannot divide the square root of 10 by the integer 2. If we're dealing with square roots and integers for multiplication or division, we cannot combine those things. We could only divide 10 and 2 if those were both integers. In this next example, we need to multiply times the square root of 3 in the numerator and denominator. That square root of 3 times itself gives us 3, and we can multiply 10 times 3 underneath the square root in the numerator, and we get square root of 30 over 3. Now let's see what happens if we have an integer and a radical in the denominator. In this example, we only need to multiply by the radical, the square root that is in the denominator. So I'll just leave that 6 alone, but still multiply by the square root of 2. In our numerator, since we have a whole number times a square root, we're not going to be able to multiply those together. We'll just leave those written separately. And in our denominator, the square root of 2 times the square root of 2 is just equal to 2. So now there's one more thing we can do in our denominator to simplify this. 6 times 2, well, we know how to multiply those. Those are just regular numbers, so we can multiply those together and get 12. So this would be 5 times the square root of 2 all over 12. And in this final example, we need to multiply times the square root of 3 in the numerator and denominator. In our numerator, we have 2 times the square root of 3. And in our denominator, square root of 3 times itself is equal to just the integer 3. And we can multiply these two integers together. 7 times 3 gives us 21. So to recap, we've talked about a couple of types of numbers. Rational numbers, which are fractions that have whole numbers in them, and irrational numbers, which are things that cannot be written as fractions using whole numbers. And common types of irrational numbers are square roots that can't be simplified. And when we've got square roots that can't be simplified in the denominator of a fraction, we want to move those into the numerator by multiplying times the same copy of that square root into the top and bottom. And just by mathematical convention, traditionally it's okay to have a square root in the numerator as long as we got rid of the square root in the denominator.